Hey guys, it's Julien from Geeklipse, and today we'll be delving deep into the world of My Hero Academia, where 80% of the population has some unique superpower or quirk. Most of the time they're relatively useless, but sometimes they may be unimaginably powerful. For this video, we'll be focusing on the quirk of one of the main character's classmates, Momo Yaoyorozu, and her quirk, Creation. Momo's quirk, quote, breaks down fat at a molecular level, which will then be reused as material for her to shape into objects with her quirk. Sounds simple enough? Eat stuff, make stuff. Except a few problems arise when you analyze it from a scientific perspective. Molecules are groups of atoms bonded together, so her quirk breaks down these bonds into the elements that they make up, then rearrange and rebond them to create new molecules and therefore new objects. However, in theory, if this were to happen, she would have two restrictions. One, the mass of her items she creates could not exceed the mass of the amount of body fat she has, and two, fat is a lipid, and lipids are made of carbon, hydrogen, and oxygen. Therefore, anything she makes should only be made of carbon, hydrogen, and oxygen. So for this video, we'll be analyzing her most massive and her most complex creations to see if they hold up to these two rules. First, we'll be analyzing two of her more massive creations. First up, we have the 100mm thick insulator sheet that she used at the attack on USJ to defend herself from Kaminari's electric discharge. Mass is density times volume, so those are the two things we'll need to find. Volume is height times length times width. We already have its height since we know it's 100mm thick, or 0.1 meters thick. And if we use Jiro, who stands at about 154 centimeters as a human ruler, then we can approximate the length and width of the sheet, which come out to be around 5.8 meters long and 1.4 meters wide. By multiplying these three numbers, we get a volume of 0.829 meters cubed. Now we need to find the density. The most common insulation sheets are made of polystyrene with a density of 1.04 grams per centimeters cubed, or 1040 kilograms per meters cubed. This means that our mass comes out to be a surprising 862.32 kilograms. Well, that's a problem. Not only for Momo, seeing as she would get crushed under the weight of such a heavy object, but also because that's equivalent to about 1,901 pounds, which is much heavier than any human. Meaning she's somehow creating more mass than she has, which goes against the law of conservation of mass. But this isn't her craziest feat. Next, we'll analyze one of her abilities from the video game, My Hero One's Justice. As you can see, she just makes 6 cannons without hesitation out of the blue. These cannons seem to be of similar height and build of the 1592 cannon, weighing around 711.7 kilograms. Multiply this weight by 6, and you get a total mass of 4,270.12 kilograms, or 31,460.2 pounds. First test, failed. Next, we'll move on to some of her most chemically complex creations and see if they match up with our second rule. First, we have flashbang grenades. The current flashbang used by the US is the M84, which utilizes a pyrotechnic metal oxidant mix of magnesium and potassium perchlorate charge to emit a flash and a loud bang through ports/holes in the cast outer body of the grenade. So our elements are magnesium, potassium, chlorine, and oxygen, which do not match up with our original restriction. Next, we have a nitinol alloy. Nitinol refers to nickel-titanium alloy. The key elements we can derive here are nickel, an element with an atomic number of 28, and titanium, an element with an atomic number of 22. Yet again, these do not match up with our rules. Side note, I did some calculations based on the density of nitinol and the volume of the ball, and it appears that it weighs about 150.8 kilograms. So it also fails test 1. So it appears that Momo's quirk doesn't follow any of the rules it should. So what could be a possible explanation for this? Well, producing more mass is a completely different story, but a possibility for producing more complex elements than available is that some sort of transmutation is occurring. Transmutation is the changing of one element to another by radioactive decay, nuclear bombardment, or similar processes. There are a few ways elements can transmute: nuclear fusion, nuclear fission, radioactive decay, and particle acceleration. Whatever is going on couldn't be fission or decay, because that relies on things coming apart, and she makes some elements with an atomic mass higher than carbon, hydrogen, and oxygen. That leaves nuclear fusion and particle acceleration. Obviously, Momo's body isn't a particle accelerator or a nuclear reactor, but if it was a nuclear reactor, then, well, Nuclear fusion is the process by which multiple nuclei join together to form a heavier nucleus. It is accompanied by the release or absorption of energy depending on the masses of the nuclei involved. So if she is indeed joining these elements together, then realistically, there is a very real possibility that the energy required would be absorbed during the process, or released, causing a very, very big explosion. Usually making lighter elements during nuclear fusion will cause an exothermic reaction, or one that releases energy, and heavier elements will cause an endothermic reaction, or one that absorbs energy. This threshold that separates the two is generally iron 56, or the most common isotope of iron. Iron can go either way depending on what elements are fused to create it, and would you look at that, all 6 of those cannons seem to be made of iron. This could either go surprisingly well, or disastrously poorly. If we assume the cannon is entirely made of iron, then the most efficient way, or the combination requiring the least amount of individual elements, would be 3 oxygen 18 atoms and 2 hydrogen atoms to create 1 iron 56 atom, which is the isotope we find on the periodic table. In an isotope, the number is its atomic mass. When transmuting, whatever goes in must have the same number of protons, which is the atomic number, neutrons, and electrons is the end result. Number of protons plus neutrons gives us the atomic mass. Oxygen has 8 protons. 8 times 3 is 24, and 2 hydrogen atoms with 1 proton each give us 26 protons, which is 1 iron atom. We need oxygen 18 because it has 10 neutrons. 3 oxygen 18 and 2 hydrogen give us 30 neutrons because hydrogen 1 doesn't have any. Iron 56 minus its atomic number is 30, so our neutrons match up. So to start, here's our chemical formula. If we calculate the mass of these atoms together, we get a mass of 56.01 AMU. However, the mass of iron 56 is 55.8 AMU. The difference between the mass of the products minus the reactants is what we call a Q value. In nuclear fusion, some of the mass during a reaction is converted to energy, which results in an exothermic reaction. Since our Q value is 0.17 AMU, which is positive, we knew that mass is converted to energy, and we have an exothermic reaction. However, this is only for one reaction. To calculate the resulting Q value after all the atoms are converted, we need to first find out how much energy was released during one reaction, then multiply it by the number of atoms in all 6 cannons. The classic formula for this we'll use is E equals mc squared, where E is energy in joules, m is mass in kilograms, and c is the speed of light. 0.168 AMU is equivalent to about 2.8 times 10 to the negative 28th kilograms. So plugging in everything, we get a release of 2.5 times 10 to the negative 11 joules for one reaction. Next, we'll take the mass of 1 iron 56 atom, convert it to kilograms, and divide the total mass of all 6 cannons, which we found earlier by it. This gives us 4.6 times 10 to the 28 iron 56 atoms that make up all 6 cannons. Finally, we'll multiply the amount of energy released during one reaction by the amount of reaction that will take place to give us a total energy output of 1.16 times 10 to the 18 joules, or 11.6 septillion joules, which is equivalent to 2.765 trillion kilotons, or 2.765 petatons. It goes kilo, mega, giga, tera, and then peta. That is gigantic. The Tsar Bomba was the biggest ever nuclear bomb detonated, and it had an explosive yield of 50 megatons. This explosion would be 55 million times that. An explosion this big would look like this. Oh, sorry, let me zoom out. This. Alright, hold on. This. Wait a minute. Here we go. You can't come back from that. The human race is doomed. An impact of that magnitude means extinction. It's millions of times bigger than the impact of the meteor that wiped out the dinosaurs. Thank you for watching my video. Please, if you have any constructive criticism or questions, feel free to comment. Also comment any video suggestions you have. Like, subscribe, and share. Julien out.